Hello everyone, this is Amit Kumar Singh. Welcome to my session on LCM and HCF. I believe you have gone through my previous session and you have understood what numbers is all about. You understood what a rational number, what a irrational number, what a even number, odd number, prime number, composite number. So going further, today I'm going to talk about LCM and HCF. From childhood, if I remember, I have heard of this topic called HCF and LCM, and everywhere, either at the time of my graduation, either at the time of schooling, either at the time of post-graduation, at the time of preparation of any competitive exam, this topic HCF and LCM used to come and I used to get confused. Now I am here to give you the answer. If someone like me is struggling with this topic called HCF and LCM, so here is the answer for you. So before I'll talk about HCF and LCM, I'm gonna brief you like some terminologies here. Like when we talk about HCF means highest common factor. The another name of HCF is GCD, greatest common divisor. And when you talk about the next terminology, that is LCM means least common multiple. Now the very important thing what we need to understand here is that we need to understand the meaning of factor and we need to understand the meaning of multiple. Okay, so let's first talk about the meaning of factor and multiple. Like if I give you a number called 20, okay, so what are the factors of 20? So the factors of 20 will be 1, 2, 4, 5, 10 and 20. So these will be the factors of 20. When I'll ask you the multiples, so what are the multiple of 20? So the multiple of 20 will be 20, 40, 60, 80, 100 and like that it will go till infinity. So when you are talking about factors, when you're talking about multiples, are you able to understand here what I mean to say that? I mean to say that like when I'm talking about the factors of 20, so the factors of 20 are 1, 2, 4, 5, 10 and 20. So factors, whenever we are trying to find out the factor, we are trying to find out those numbers which can divide 20. When I'm talking about multiples of 20, I'm talking about those numbers which will come in the table of 20. So the multiple of 20, mathematically I can write this as 20i. Where mathematically I can say the multiple of 20i in the form of 20i, where I can define I are all your natural numbers. So all your natural numbers are basically your I. So multiples, when we are talking multiples you are getting numbers which are in the times of that same number. So when I'm talking multiples of 20, we have 20, 40, 60, 80, 100, 120, 140 like that, and that will go till infinity. When I'm talking factors, I'm finding those numbers which can divide 20. So always when we talk about factors are either that number or lesser than to that number. When I'm talking multiple means that number or some numbers which are bigger than that number. So are you able to understand the difference between factors and multiple? Now it's very important for you to understand. Now using this concept, I'm going to talk about LCM and HCF. Okay, now for example, suppose if I have taken two numbers, suppose those numbers are 16 and 24. Suppose I am talking about two numbers called 16 and 24. Now when I talk about 16 and 24, if I ask you to determine the HCF and LCM of 16 and 24, what you will do, you will write 16 comma 24. You will see which number they can divide. So you can divide by 8, this will be 12, then you divide it further, then you will get 4. Here you get 6, then you divide it further, you get 2, you get 3. Now if you see now there is no number which can divide 2 and 3 at the same time. Are you able to understand this? So when I am dividing the 16 and 24, so I got 2, 2, 2, and after 2, 2, 2, I am not getting any single number which can divide 2 and 3 simultaneously. So now these 2 and 3 are basically called as co-prime number. Co-prime numbers are basically those numbers which have HCF of 1. Already I have discussed about co-prime number in the previous class. I believe everyone remember that part. Good morning Aditya, good morning Krish. Welcome to the session. Now here like when I'm talking about 16 and 24, so the HCF of 16 and 24 is basically 8. 2 into 2 into 2, you will get that value 8. Now if you see, now I'm not getting any number which can divide 2 and 3 at the same time. So that gives me the value of HCF. So the HCF of 16 and 24 is basically what? Is basically 8. Is it clear? Now when I'm talking about LCM, so LCM I'll go further. So I'll keep doing till the time I don't get the all the numbers as 1 and 1. So this I'll get 1 comma 1. So here when I'm talking about HCF of 16 and 24, HCF means highest common factor. So highest common factor, the biggest number which can divide both the number at the same time. What is the biggest number which can divide 16 and 24 at the same time? So that biggest number is 8. Once you divided this number by 8, now you are not getting any other number which can divide it further. Once you divided it by 8, now the numbers which are left are co-prime number. There is no number which can divide it further. So that's why you are getting this value called 8 as the HCF. Now when you talk about LCM, so LCM of these number will be 2 into 2 into 2 into 2 into 3. You can see. So 4 times 2 is coming into 3. So what is value you get? You get 48. So the LCM of 16 and 24 is what? Is 48. Is it clear, Aditya? Is it clear, Krish? Is it clear, everyone who are listening to me? Hope you are understanding, right? So now when I'm talking about LCM, so the LCM of 16 and 24 is 48. The HCF of 16 and 24 is 8. Now you would be wondering, this we are doing from childhood, right? Whatever I have talked, everything is you know, and you heard of all these things. HCF, LCM, and sir, you got HCF as 8, you got LCM as 48. What is big deal in that? Now we need to understand, that is the big deal. Now when I'm talking about 16 and 24, the LCM of 16 and 24 is 48. What that mean? That mean that 48 is the smallest number. 48 is the smallest number which is divisible by 16 and 24. If I ask you how many numbers are there between 1 and 1000 which are divisible by 16 also and 24 also. So when I'm asking you how many numbers are there between 1 and 1000 which are divisible by 16 also and 24 also, so you don't need to run behind the multiples of 16 and then you write the multiples of 24 and you see the common number between them, that those who know set theory, so intersection of the two element, all that thing you don't need to bother about. The moment you found out the LCM gave you the smallest possible number which is divisible by 16 and 24. What will the next number after 48? So the next number after 48 is 48 2za. So 48 2za is 96. What will the next number? 144. What will be the next number? 192. What will the next number? 240. So all these numbers, what I'm writing just the table of 48. So all these numbers are basically the number which are divisible by 16 and 24. But you don't need to bother about this number. The moment you got the LCM, you got the least common multiple. The moment you got the least common multiple, you just focus here. Like if I ask you how many numbers are there between 1 and 1000 which is divisible by 16 and 24 at the same time, so you got the LCM, right? LCM was 48, just divide that number. So what is the largest 3-digit number? What I ask you, from 1 to 1000 means 1 to 1000 you can write the number, you can write 999, you can write 1000 also, that doesn't matter. If I divide it by further, so 48 2za, you get 96, so you get 39. Now 39 means 20. So how many numbers are there which are divisible by 16 and 24 from 1 to 1000? So the numbers are 20 numbers are there. Is it clear to you? Are you able to understand this? Yes or no? Say Aditya. Hi Swati. Aditya, have you understood till now what we discussed? Krish, Swati, welcome to the session. Clear, right? So I'm talking about the application of LCM. So here in that application of LCM, when the moment we found the value of the LCM, we got the smallest possible number. The moment we got that smallest possible number, now we just need to concentrate on that number. So the smallest possible number is 48. Now you got the 48. Now on the basis that whatever question I'm going to ask you, just do that logic. So if I ask you like what is the largest 3-digit number? What is the largest 3-digit divisible by What is the largest 3-digit number divisible by 16 and 24? If I ask you, what is the largest 6-digit number divisible by 16 and 24? Welcome to the session, Vishaka. Please be on time. So what is the largest 3-digit number divisible by 16 and 24 if I ask you? So guys, coming back to the session, what I did, I took the largest 3-digit number. 3-digit number was 999. That 999 I divided by 48. Why I divided by 48? Because 48 is the LCM. So when I divided by 48, what reminder you got? You got the reminder called 39. So if I am asking you what is the largest 3-digit number divisible by 16 and 24, so that number will be 999 minus 39 and you will get 960. So what is the largest 3-digit number which is divisible by 16 and 24? Your answer will be 960. Is it clear to you? Yes or no? Fine. I am expecting everyone reply. Okay, fine. Everyone is understanding. I am happy. Now, the next question, I can go further. I can ask you, what is the smallest 4-digit number? What is the smallest 4-digit number divisible by, what is the smallest 4-digit number divisible by 16 and 24? If I ask you, so what is the smallest 4-digit number divisible by 16 and 24? Can anyone tell me the answer of this question? You just need to use the same logic. Think, tell me. So what is the smallest 4-digit number divisible by 16 and 24? So first I'll write the smallest 4-digit number. So this is the smallest 4-digit number. Fine. Now I'll divide this by 48. Why I'm dividing it by 48? Because 48 is the LCM of 16 and 24. So the same thing, guys, what I did before, you just need to divide it further by 48. So when you're dividing it further, what you are getting, guys, reminder, you are getting the reminder called 39. Fine. And you understand that the largest 3-digit number which is divisible by 16 and 48 is 960. So what will be the next number? So next number will be nothing but, if you add 48 to this, so what you will get? You get 1008. 1008 is the smallest 4-digit number which is divisible by 16 and 48. You don't need to do anything. You can do this. You divide it 96, you get 40, you get 0. So if you write it again 0, so you get 40. So 40 as a reminder, if you subtract 40 from 1000, you get 960. So 960 is the largest 3-digit number. If you have to find the smallest 4-digit number, so what you need to do, you understand the table pattern. So the table pattern, if I am saying 2 3s is 6. So next number will be, if I want to know what is 2 4s, so what I'll do, either you determine 2 4s or 2 3s is 6, on the 6 add 2, the same logic. So here when you are finding 48 into 20, 48 20s is 960. If you have to find the next number, 48 21s is 1008, and that is your smallest 4-digit number. Is it clear to everyone? Yes or no? Tell me. Everyone understood? Vishaka, very good, awesome. Krish, very good. Walker, very good. You are very good. You all are doing very well. So like, guys, now if I ask you the similar question like this, what is the largest 3-digit number which, when I divide it by 16 and 24, will give me the remainder 3? Tell me this. What is the largest 3-digit number which, when I divide it by 16 and 24, will give me a remainder of 3? Guys, I'm waiting for your answer. What is the largest 3-digit number which, when I divide by 16 and 24, will give me the remainder 3? Guys, your answer is 963. So 960, guys, 960 is your largest 3-digit number which is divisible by 16 and 24. I'm not asking divisible. I'm asking it should give me the remainder 3. Is it clear? So your answer will be 963. Very simple. Fine. If I ask you a question like this, what is the largest 3-digit number which when get doubled is divisible by 16 and 24? Vishaka, very good. Now, Vishaka, tell me the answer of this question. Others also. Walker, Krish, Aditya, I'm expecting the answer for this question. Listen this question. What is the largest 3-digit number which when get doubled is divisible by 16 and 24? Waiting answer, everyone. What is the largest 3-digit number which when get doubled is divisible by 16 and 24? Your answer is nothing but 480. 960 is the number. So what do you do? I'm asking that number which when I double is get divisible by 16 and 24. So you know that the answer is 960. Divide 960 by 2. You got the answer 480. Is it clear, everyone? Okay, good. So going further, if I want to know, you have to tell me the LCM of 36, 42 and 56. Tell me what is the LCM of 36, 42 and 56. See, so 36, Shaka, Aditya, everyone, you all can hear me, right? Done. Very good. Awesome. So guys, coming back, what I was talking about the LCM of 36, 42 and 56. So I'm going repeating the same thing. So when you have to find the LCM by divisibility way, I believe everyone knows how to find the LCM by divisibility way. I'm going to talk about the other way also. You can find the LCM and HCF through prime factorization way also. So I can write 36 as 2 square into 3 square. I can write 42 as 2 into 3 into 7. I can write 56 as 2 cube into 7. Is it clear to everyone? You know how to break it further, right? 56 is 8 sevens are 8 is nothing but 2 cube into 7. 42 is 2 into 3 into 7. We know all this way. Now how to find the LCM? So once you wrote the number in its prime factor, now what you do, guys, you need to focus on the highest power. Guys, what is the highest power of 2 here? So the highest power of 2, guys, here is 3. So write the highest power is 3. 2 to the power 3. Now what is the highest power of 3 here, guys? The highest power of 3 here is 2. So write 3 to the power 2. What is the highest power 7 here, guys? So highest power 7 is 1. So the LCM of these number will be 2 cube into 3 square into 7. That is nothing but 8 into 9 into 7. 8 into 9 into 7 is nothing but that is your 504. So if you do 8 9s are 72, 72 7s are if you do, you will get 504. Same thing. Is it communicable? Are you able to understand that thing? Very easy, right? So you can do the same thing either by divisibility way, or you can do the same thing, guys, by following the prime factorization way. Both way if you do, you will get the same answer. My objective is to communicate another way of finding the LCM. Clear, right? Everyone understood, right? Now I'm going to talk about HCF. Similarly, I'm going to talk about how you can find the HCF of the number, highest common factor of the numbers. Like I want to find the HCF of 288 and 432 and 768. I want to find the HCF of these number. So Now the objective is to find the HCF of these numbers. So you can do the same way. You can divide 288, 432 and 768 and think of the number by which all three are divisible. So they are divisible by they are divisible by 4. So they are divisible by 2. You can see what others number they can be divisible. You can find it out. So they are divisible by 8 also. So like that way you can use the divisibility rule also. Okay, here guys, what is the divisibility rule of 2? That this should be even number. What is the divisibility rule of 4, guys? What is the divisibility rule of 4? Anyone can tell me? Aditya, Krish, anyone? What is the divisibility rule of 4? What is the divisibility rule of 4? The divisibility rule of 4 is that last 2 digits should be divisible. So 88 is divisible by 4. Yeah, so it's divisible by 4. Now 32, is it divisible by 4? Yes. 68, is it divisible by 4? Yes. Now what is the divisibility rule of 8? Divisibility rule of 8 is last 3 digits should be divisible. So when you see 288 is divisible by 8. Now when you see 432 is divisible by 8. When you see 768 is it divisible by 8? Yeah, it is divisible by 8. What is the divisibility rule of 16, guys? Last 4 digits should be divisible. Same pattern you just need to use. Clear, right? So when I want to find the HCF of 288, 432 and 768, you can do by normal divisibility way you can do, or other way I want to tell you. The other way what you can do, divide 768 by 432. Divide 768 by 432. You can do this way also. You can find the HCF by this way. Divide 768 by 432. So 432 twos are, guys, if I do, what I will get, I'll get a bigger number than 768, right? You can see this 4 twos is 8. Here 768 is there. So when I'm talking about like what would be the 432 twos are. So 432 twos are, you don't need to get panic. Don't waste your time. So 432 ones are. So you get remainder as 6, 3 and 3. You get 336 as remainder. Now whatever is your remainder, that will become your divisor. Now divide 432 by 336. Again, when you are observing 336, twos are will be something in 600s. Here the number is 432. So you need to do ones. So 336, you get 6, you get 96. Now 96 become your divisor and 336 become your dividend. Fine. Now, very good. Aditya, very good. You got the correct answer. The answer is 48 only. Now divide 336 by 96. So 96 5s is 480. Okay, how to find the 5s? Like I told, 96 5s is 480. How I did? So 96 into 10 divided by 2, 480. So if I find the 96 4s, so 96 4s, if I find, I get 24, I get 384. So that will be bigger number. So 96 3s, if I do 18 288. So 3s I'll take 288. So I'll get 8 and here I'll get 4, 48. Now 48 become your divisor and 96 become your remainder. So 48 2s is 96. So that is completely divisible. So that means 48 is the HCF of 432 and 768. So when I ask you find the HCF of 288, 432 and 768, you can either do by normal divisibility way, or this is the other way I want to communicate to you. Take two bigger number, divide the biggest number by the next bigger number, and whatever you get, the remainder will become your divisor, and the divisor of previous calculation will become your dividend, and do it further till the time you get a number which can divide it completely. So here the number which can divide it completely is 48. So 48 is the HCF of 432 and 768. So you found out 432 and 768, you found out their HCF is 48. Now what you do? Check, is 288 divisible by 48? So 48 in 8 table, where you get 8 6s. So if you check 488 6s, you get 288. Hence 48 is the HCF of 288, 432 and 768. Is it clear to everyone? Are you able to understand? This is the other approach. You can Similar to the approach what I have communicated, this is the other way you can find the HCF of the number. And otherwise, the divisibility rule is always welcome for you. Now this same I can write it 288, I can break it in its prime factor, 288, 432 and 768. If I write the prime factor, so 288 is nothing but 2 into 44, so 2 into 12 square, that is 288. So 12 is 2 square into 3, 2 square, so you get 2 into 2 to the power 4 into 3 square. So when you talk about 288, that is 2 to the power 5 into 3 square. 2 to the power 5 is 32, 32 nines are, 32 nines are you will get 288. Now 432, if I break 432 in its prime factors, you get 216, then you get 108, then you get 54, then you get 27. Now 27 is 3 cube, so 1 2 3 4, so this is 2 to the power 4 into 3 cube. Now 768, so 768 I can break it further, that will become 384, then you divide it further, that will become 192, then divided further, that will become 96, divided further, that will become 48, divided further, that will give you 24, divided further you will get 12, divided further you get 6, divided further you get 3. So you are getting 1 2 3 4 5 6 7 8, so 2 to the power 8 into 3. Fine. So here when you want to find the HCF, like at the time when I was talking about the LCM, what I told you, just write the numbers like this and then see their highest power. Here in the case of HCF, if I want to find the HCF, I'm talking about HCF. So here when we are talking about HCF, so here what would be the HCF of 288, 432 and 768 if I want to find the HCF? So what do? Take the least power. So what is the least power of 2 here? The least power of 2 here is 4. What is the least power 3 here? The least power of 3 here is 1. So 2 4s are 2 to the power 4 is 16, 16 3s are is 48, and you will get the HCF as 48. Is it clear to you? Are you able to understand it? Everyone say yes. Yes, Swati, last 2 digits should be divisible. That is the property to check is that number divisible by 4 or not. Last 3 digits should be divisible. That is a property of divisibility rule of 8. Last 4 digits should be divisible. That is a property that the number should be divisible by 16. Remember that logic of divisibility rule of 4, guys, is very important when you find out the unit digit of a number. Any number 2 to the power 69, what is a unit digit? So that logic of divisibility rule can be applied to that. So guys, now talking about the previous question, like in the last class I have given you one question that from if you write the number from 1 to 1000, how many times the digit 2 will be written. So what was the answer for this question, guys? So the answer for this question was 300. How to get the answer 300? So I can explain you. So you can explain it that case 1, when 2 came once. I can write 3 cases, when 2 came 1 time, when 2 came 2 times, or 2 can come 3 times. Guys, when you are writing the number from 1 to 1000, so actually 1 to 1000 means you are actually talking about 1 to 999, right? You are talking about 1 to 999. So here I can talk about when 2 came once. So when 2 came once, so here 3 cases can happen. When 2 is coming once, these are the 3 cases when the 2 came once. So here when the 2 came here once, now the 2 places are left where any 9 digits can come. 2 is coming once. So how many digits are there, guys? Indians have discovered that base system of 10. So we have 10 digits, right? And 2 cannot come. So how many digits can come here? In first place, any 9 digits can come, and in second place, any 9 digits can come. So any 81 numbers can come here, any 81 numbers can come here. So how many numbers will be there? 243. So how many numbers 2 is coming once? In 243 numbers 2 is coming once. So this is the one case. The second case, case 2, when 2 came twice. When 2 came twice. So when 2 came twice, so here again 3 cases can be developed. So here one place is left. So in that one place any 9 numbers can come. Any 9 numbers can come. Fine. So here 9 3s are 27. How many numbers are there? 27. In 27 numbers 2 came 2 times. But 2 came 2 times means 2 is in all these 27 numbers 2 is coming 2 times. So how many times the 2 came here, guys? 27 2s are. You will get 54. So when 2 came once, so 2 came once 243 times. When I ask you when 2 came twice, that happened 54 times. And when I'm asking you third case will be when 2 came thrice. So guys, from 1 to 999, how many times the 2 will come thrice? How many numbers can be possible? So only one number can be possible. That number is 222. Here the 2 came thrice. Fine, there is only one number. In that 2 came thrice, means 3. How many 2 came here? 3. So the answer is 300. If I ask you that from 1 to 10,000, how many times the digit 2 will be written? I believe you can think on this part. From 1 to 10,000, how many times the 2 can come? So the answer will be 4,000. Think on this part. If you have any doubt, we can discuss in the last class. So guys, it's a time for your contest time questions. I believe you will be waiting for this question from the time we started this session. So hence, now your question is gonna flash in your screen for in the couple of seconds, and then I'll wait for only for 40 seconds, and I'm waiting for your answer. Your time starts now. So the question is that what is the minimum number of square marbles needed to tile a floor of length 5 meters 78 centimeter and width 3 meters 74 centimeter? I'm expecting answer. Everyone start solving. Use your logic. What do you need to find here? Your time up, and I believe everyone would have solved the question and will give me the answer very soon. Expecting answer from everyone. Anyway, take your own time, and all the student who can give me the answer for this contest time will get one free atom session with the concerned faculty. So don't wait and start solving. So anyway, I'll go further. I'm gonna discuss it more. I have to discuss other questions also for you. So suppose your question is like this. Your question is, if the LCM of two number, the LCM of two number, the LCM of two numbers is 630 and their HCF is 9, and the HCF is 9, if the sum of the numbers, if the sum of the number is 153, if the sum of numbers is 153, find the difference, find their difference. So anyone, how will you solve this question? Think, tell me. The LCM of two numbers is 630 and the HCF is 9. If the sum of two numbers is 153, what is the difference? So guys, when you are getting the question like this, what will be your first approach? If you see here, everyone, that the LCM of these two numbers is 630 and the HCF is 9. So we are talking about two numbers and the HCF is 9. So what you will do, guys? So take the first number. What you can do, when you are finding the solution of this, when you're finding the, sorry, 1 minute. So when you're finding the solution of this, since the HCF of two numbers is 9, so take one number as 9a and another number as 9b. Now you do wondering what I did. So if the HCF of two number here is 9, the HCF of two number here is 9. So take one number as 9b and other number as 9a. So why I am doing this? Why? What happened to me? Why I am writing 9a, 9b? Because the HCF of the two number is 9. So the highest common factor between the two number is 9. So I am writing one number as 9a and other number I am writing as 9b. Where what are a and b? Where a and b are your co-prime numbers. A and b are your co-prime numbers. What are co-prime number? Co-prime numbers are those numbers which have their HCF 1. So here I took those numbers as 9a and 9b. So if the two numbers what I have taken are 9a and 9b, so what will be the LCM of these two numbers? So what will be the LCM of 9a and 9b, guys? So the LCM of 9a and 9b will be 9ab. So the LCM of 9a and 9b will be 9ab. So since the HCF of two number were 9, so I took one number as 9a, other number would be 9b. Now the LCM of these two number will be 9ab, and that 9ab is given to you as 630. So you can say AB is equal to 70. So AB is equal to 70. Now the sum of these two numbers means 9A plus 9B. Now the sum of these two numbers is 153. So I can write A plus B is equal to 153 divided by 9. If I do, what I'll get? I'll get 17. So guys, think of two numbers. What are those numbers? Whose sum is 17, and when you multiply, you should get 70. So what can be those numbers? 17, sum. Think of how many possible numbers. Think of the numbers. Okay, if you are getting confused, think of the two numbers whose product can be 70. So one number can be 1 and 70. Okay, so the sum of 1 and 70 can't be 17, right? So what can the other number? Product should be 70, that can be 2 and 35. So 2 and 35 sum is also not 17, so this is also not possible. What can be the other number? So other number can be 5 and 14. So 5 and 14 sum, is it 70? No. So what can be the other number? 7 and 10. So if I take 7 and 10, when I am multiplying 7 and 10, I am getting their product at 70, and when I am adding 7 and 10, I am getting 17. Means my A is 7 and my B is 10. So that means my first number, that is 9A. So 9A will be 9 7s are 63, and 9B will be 9 into 10, 90. What is 90 minus 63? Your answer is 27. Is it clear? So I believe you have understood this question, and this question give you very important property of HCF and LCM. when you're talking about HCF and LCM, the very important property what we need to understand here is that if two numbers are given to you and those two numbers HCF is X, if two numbers are given to you and the HCF of the two number is X, so if the two numbers are given to you and the HCF is X, then take one number is XA and other number is XB, where A and B are your co-prime numbers. And if two numbers are there which are XA and XB, so the LCM of these two numbers will be XAB. Is it clear? Everyone understood, right? Very good. So again I'll re-emphasize the same thing whenever you are solving the question, and in that question if they mention the data of HCF, HCF can be anything, keep that in your mind when you are solving the question, and if HCF is given you some X, so take one number as XA, other number is XB. Similar questions like this are there probably for all the passport users. I have created well defined 10 difficult questions only for the passport users who can get the benefit of these questions and they can solve questions like this tremendously. So this is one of the question, and these like questions comes in many competitive exams, trust me. So this is the one of the question. You can go further, you can discuss about the other properties of HCF and LCM, guys. Going further, I can talk about properties of HCF and LCM as the product of two numbers. When you're talking about two numbers, the product of their two numbers is the multiplication of HCF of two number and the LCM of two number. So this can be the other property, guys, which you can use while solving the question, that the product of two number is equal to the HCF of two number into LCM of the two number. Always remember one thing, that the LCM is always the multiple of HCF. Always remember, LCM is always the multiple of HCF. Keep this in your mind. So when you are solving the question in few exams and all, you get questions like that where you get the value of HCF and LCM, but when you are getting that value of HCF and LCM, always remember to check this test, and if the number satisfying this test, then will you proceed with the answer. So that last minute check always keep in your mind when you are solving the question. Is it clear, right? Everyone, are you able to understand me? Say yes, everyone. Aditya, Swati, Vishakha, everyone, are you able to understand? Any doubt till now? Ask me. So guys, another question for you, that suppose the question is like this, that 4 electronic devices beep, sorry, that is beep not deep, beep after 30 minutes, 1 hour, 1.5 hour and 1 hour 45 minutes. Fine. So all beep together at 12 noon. Fine. So when again they will beep together. So this question, when I'm asking you, if you want to solve this question, guys, very easy you need to solve. In order to solve this question, you just need to convert this data 30 minutes is there, 1 hour is there, 1 hour 30 minutes is there, 1 hour 45 minutes is there. Convert all them into minutes. So if you convert them all them into minute, you get 30, you get 60, you get 90 and 105. Find the LCM. I believe you all know how to find the LCM of these number. Find the LCM of these number. So if I find the LCM of this number, so if I divide by 5, you get 6, you get 12, 12 5s are 60, you get 15, you get not 15, you will get 18, 18 5s are 90, and then you get 21. Then you can divide further by 3, so you get 2, you get 4, you get 6, you get 7, then divide further by 2, you get 1, 2, 3, then 7, then you can divide it by 2, 3 and 7. So the LCM of these number, if you find the LCM of this number, that is nothing but 15 into 5 into 3 is 15, 15 into 2 is 30, 30 into 2 is 60, 60 into 70, 60 into 70 is what? 15 into 3 is 5 into 3 is 15, 15 into 4 is 60, 60 into 21. So 16 into 21, guys, if you do, you will get 1260 minute. 1260 minute. If you convert this into hour, what you will get? You will get 21 hours, guys. So when they will beep together, again they will beep together after 21 hour. Already they had beeped at 12 noon. So after 12 noon, what is 21 hours after 12 noon? So 12 noon means 12 p.m. 12 p.m. to 12 p.m. That would have been 24 hours. So 3 hours before that, that will be your 9 a.m. So your answer is, guys, 9 a.m. Is it clear? So guys, when you're solving the question like this, and suppose the similar application I can use for the circular motion also. Circular motion, if I gave you that the circumference of a circular track, suppose I gave you a question where the circumference of circular track is given to you, and A can complete the round in X seconds and B can complete the round in Y second. If I ask you when they will meet at the starting point, then what you need to do, guys, you need to find the LCM of the number. So LCM as a topic is very, very important. You talk about any competitive exam, you talk about any chapters on maths, you talk about time, speed and distance, circular motion, you talk about time and work. Everywhere the application of HCF and LCM works. So keep remember this point in your mind. Similarly, if I'm talking about it, whenever you want to know the HCF and LCM of fractions, remember LCM of fraction is nothing but LCM of numerator divided by the HCF of denominator, and HCF of fraction is nothing but HCF of numerator divided by LCM of denominator. Using that property, you can solve lot of questions, guys, and that ultimately made me to reach that point where I need to give you the time for all of my passport users to start solving the difficult 10 questions what I have created for you. And now it's time, you just need to start solving the question. Best of luck, your time starts now.